Alright, so trig proofs. Now we have particular identities that we can simplify our trigonometric functions with. So for instance, our tan function, tan theta, how else can we write tan theta? Sine over cos. Tan theta is sine theta over cos theta. Okay? And then we also have cot. Now what's cot theta? 1 over tan theta, which is the inverse of tan theta. So cot theta would be cos theta over sine theta. As well as this, we have a couple of other trig functions that are derivatives of sine and cos. So I'm not going to go into the specifics of where these come from. I do have notes on the learning place of the proofs, I guess, of these functions. And if you're interested in that, you can come and see me and I can go through it with you. But I just don't think that this is the time for that. But we have sec theta, and all sec theta is 1 over cos theta. Okay, so it's the inverse of cos theta, and then what we can also say is, well, I guess if sec theta is 1 on cos theta, then cos theta is 1 on sec theta. And we also have another one called cosec, and I write that CSC, cosec, which is 1 on sine theta, and then obviously, like that. So cosec, CSC, which is, we can also write sine theta as 1 on cosec theta. So each of our functions, so sine, just like sine has cosine, tan has cotan, which is cot, and sec has cosec. And they all essentially come from sine. Remember, cos is just sine with a horizontal shift. So, pretty much all of these functions we could write as some combination of sine. Anyway, we also have what's called our Pythagorean identity. Now if we have our unit circle, I'm just going to do a quarter of our unit circle. So if we have some angle for theta here, the vertical side, let's call that y, and let's call the horizontal side x. And what's the hypotenuse of that triangle? Hypotenuse is 1, because it's a unit circle, right? So we could say that, well, using Pythagoras, wouldn't x squared plus y squared, wouldn't that be equal to 1? 1 squared, which is 1. You guys agree with that? Now what is y? Y is sine theta and x is cos theta. Okay, so we can actually say, well, cos squared theta plus sine squared theta is equal to 1. And I can demonstrate this. Just quickly on here. So we have, someone pick a number, any number, 7. So if we go sine times sine of 7 squared plus cos of 7 squared, anyone want to guess what it's going to be? 1. Okay? And as long as these values are the same, it's always going to be equal to 1 because of this identity. Now, I'll point out, I'll just mention this partly for the video, partly for anyone. This, we write it like this because if we wrote if we wrote it like that, because cos squared theta, we're squaring the whole thing. So that's like, the reason we write it this way is because if we wrote cos theta squared, is that the theta squared or is that the whole thing squared? We're not sure. So we write it, so cos squared theta is the whole thing squared. That's not really something we have to worry about too much, but we just have to keep in mind that's how the notation works. Okay, now there's a few from our Pythagorean identity. Looking here, we can go, well, if we have, this is an equation. So we can rearrange this equation, and we can say, well, cos squared theta is going to be 1 minus sine squared theta. Okay? Because all I've done is I've taken sine squared theta away from here. I can also take the cos squared theta and I can go, well, if I have sine squared theta, that's equal to 1 take cos squared theta. Okay? So I've got these identities. So anywhere I see this, I can sub in this, and vice versa. Okay, and we're going to see a few areas where we can use that. I'm going to mention another one. Now, I'm going to pause the video for a moment.